This lesson is on exponential modeling, percent growth and decay, and compound interest. By the end of this lesson, you should be able to use the exponential models to solve growth and decay problems, identify all parts of the equations, and understand how they affect the outcome. Exponential functions are very important in modeling a variety of real-life phenomena because certain things either increase or decrease by a fixed percentage over given units of time. Exercise 1. Suppose that you deposit money into a savings account that receives 5% interest per year on the amount of money that is in the account for that year. Assume that you deposit $400 into the account initially. How much will the savings account increase over the course of the year? So, which parts are important? Well, we are receiving 5% interest per year, and we initially deposited $400. So, we're going to make 5%. Well, what is 5% of $400? So, we can take our $400 and multiply by 5%. All right, so we're going to grab our calculators. Do you remember where your percent button is? So we're going to do $400 times, and remember percent is next to the G, so 5% button. So the first year, we're going to make $20. How much money is in the account at the end of the first year? Well, is only our $20 in there? No, we started with $400 and we made $20 in interest. So this is the initial and this is the interest. So we have a total of $420 at the end of the first year. By what single number could you have multiplied the 400 by in order to calculate your answer in part B? Well, if I was just going to keep 400, that's my original amount. That's 100% of what I started with, correct? So I added to it 5%. So what's 100% plus 5%? Well, 105%. Well, I need a single number to represent that. So what is 105% as a decimal? Well, again, you could use your calculator. So 105%. And you got a fraction, so hit Control Enter. So 1.05. Well, think of that. 100% is 1, plus 5% is 0.05. So we're earning the money we had plus an additional 5%. So we're multiplying 400, so let's make sure. So let's take our 1.05 and multiply by 400. And we end up with our 420. Excellent. So given an equation for the amount in the savings account, S of t, as a function of the number of years since the 400 was invested. So we have to come up with an equation for the amount of in the savings. Well, what did we start with? Do you remember this from our last lesson? 400. And we're multiplying by 1.05. Our variable is t for time. So using a table on your calculator determines the nearest year how long it will take for your original amount to double. So let's grab our calculators, get a graph, because they asked us to use a table. We're putting in our equation, 400 times 1.05 raised to the, we can't do t this time because it's in f of x form. We see nothing, but again, who cares? We want to use the table, so we're going to Control T. We're looking for double, so double is 800. Ooh, went way past it. So 800 occurred somewhere between the beginning of the 14th year and the beginning of the 15th year. So on your paper, you're going to write S of t equals 800, because that would be double, correct? So your table, X and Y, you're writing 14 years gave you $791.97. Your 15th year gave you $831.57. So what is our answer? Well, during the 14th year or by the 15th year, our investment will double. All right, pause the video, read the information in the box. Go ahead and give exercise 2 a try. So just like our last lesson, Q of t is our end value. Q sub 0 is our initial value. That's our value at time 0. P is the percent increase. It's going to be a minus if it's decrease, and T is your time. So, which of the following gives the savings S in an account of $250 was invested at an interest rate of 3% a year? Well, $250 is our start value, so $250 has to be first. Well, we're not adding $250, or we're not adding our interest to $250. We know it has to be in this form. So, all the rest look pretty good. We need to know what 3% a year is as a decimal. So again, if you're not sure, use your calculator. So 3%, you put it in your calculator, is 0.03. So it can't be this one, and it can't be this one. So your answer is choice 2. This was your initial amount. This is 1 plus your P. All right. Decreasing exponentials are developed in the same way, but have the percent subtracted rather than added to the base of 100%. Just remember, you are ultimately multiplying by the percent of the original that you will have after the time period lapses. Huge, majorly important. Let's highlight. So exercise 3, state the multiplier or base you would need to multiply by in order to decrease a quantity by the given percent. So remember that is in the parentheses. So we're taking this percent away from 1. So 1 minus 10%, plug that in your calculator, you get 0.9. 1 minus 2% is 0.98. Pause the video, do the next 2, start the video, check your answers. 1 minus 25% equals 0.75, and 1 minus 0.5%, be careful, is 0.995. So just like our growth, our decreasing, or sometimes called decay or depreciate, is in the same format. So go ahead and read number 4, try it. Then start the video again. So you should have set your equation up to look something like this, and I used P for population in terms of time. My initial amount was 12,500, 1 minus my rate of decrease raised to 10 years. So my answer is choice 4. All right, pause, read exercise 5. It's a lot of words. You definitely need your calculator for this one. So, wind power, increasing at 4% per week, started at $20 per share. Durable energy was crashing, losing 11% per week, and it started at $120 per share. We need to know when they're the same, and they tell us to find this graphically. Well, I need to know what to plug in. So let's state our equations. So increasing, we are going to do $20 times 1 plus 4% raised to some time t. It has to equal $120 to start times 1 minus 11% to t. So I'm going to graph. So grab your calculator and get a graph. I'm going to graph both sides of the equation, each one in a different line. So f of 1 is going to be wind, f of 2 is going to be gerbil. Remember, you can't use t as your variable, you have to use x. Hopefully in your head you're making that funny noise I make about not seeing anything on the graph. Well, since we have to graph this, we have to manipulate these numbers. We've got to change what we see. Our starting values were 20 and 120, so I'm going to try 150. Hit tab. Nice. I need to know where they intersect, so I notice it's pretty close to 10, so I'm going to try 20. Hit tab. I only need quadrant what I see, so I'm going to leave that 6.67 and just hit enter. So now I'm going to move these equations out of the way. They are color-coded, so that's good. The things that I need to know, well, notice this hits the x-intercept at 2, or 20, I guess that would be. And this one, 150, would be up there. So we're going to have to figure that out. So let's sketch these, and then we can label. I only need quadrant 1. So my x value was 20, my y value is 150. We notice the blue one, which is the wind, grows very slowly, but it is somewhat curved. And we notice that the other one is decreasing relatively rapid, which is 11%. Let's label on each y-axis their y-intercept. That's important. So Control T. So we notice at 0 we have 20 and 120, which we already knew that. So this one is 20, and the other one is 120. I want you to be able to see what I've got on my paper so far. So I need to do my labels. So x is the exponent, which is time, and y is the cost per share, or stock price, let's call it. That's what they asked for. So we have to go back to our graph and find where they intersect. I'm going to get rid of my table, menu, geometry, points and lines, intersection. Click on red, click on blue, hit escape to turn it off. There it is. So let's label that on our graph. So we have 11.5037, comma 31.4034. If you have less decimals, it has to do with this menu button and settings. Yours may be on float 6, so make sure to get it on float. These two don't matter. And then hit make default. Okay, and you should see yours change. So now let's go back to our paper, and it asks us to find the stock price equal to graphically. So x is time, y is stock price. Can I have that many decimals? No. So the stock prices are equal at $31.40. The time, so the stock prices are equal at $31.40 in week, all right, how about let's say during week 11. If you have any questions, make sure you ask in class. Good luck.